Hello, this is video chapter 6.4, the nth root. All right, so in here, let's look at to see what our objectives are. So basically, we're going to learn to simplify radicals, and we're going to learn to use a calculator to approximate simplifying radicals. So let's look at our vocabulary real quick. Let's go through that. So the first thing we have is the nth root. Basically, that's saying the inverse of raising a number to the nth power. That's what an nth root is. This symbol indicates the nth root. That little n in there says the nth root. This is the radical sign. The index is that n which goes inside the v, and then it tells us the number of factors that must be in the radicand in order to take one out of the radical. So what is the radicand? That's any value that's under the radical sign. It could be a variable, it could be a number, it could be a symbol. And then our last vocabulary is principal root. It's just basically saying it's the positive nth root. So let's start with some basic definitions of and go back over the vocabulary of the symbols and let's look at them, what they really mean. So the definition of nth root really says for any real number a and b and any positive integer n, if a is raised to the n and it equals b, then you can say that a is the nth root of b. So that would just be, for instance, -3 raised to the fourth power is equal to 81. So -3 is the fourth root of 81. So radicals undo powers. So let's look at this basic setup. So we've got, So we've got a radical sign, right? This is our radical sign. And this here, 81, is my radicand because that's what's under the radical sign. This number here is n. We call this our index. Okay, and again, that tells us how many factors we need. If there is no number here, it's always implied 2. So for instance, the square root of 81 can be rewritten, right? Because 9 times 9. There's nothing here, so it's an implied 2. Meaning I need to have 2 of the same factors. They don't have to be prime. They can be. Sometimes it's easier to prime them all the way down. But they don't have to be. As long as I have the same factors, I have 2, so I'm going to take 1 out. I have nothing left, so the square root of 81 is 9. Now, let's look at the chart here, the next chart on our So when we talk about real n roots, remember what a real number is. So suppose n is an integer, and they're talking about n as the index, that's greater than 1, and a is a real number, and a being the radicand. Here's what it says. So when the radicand is positive, that's what this column right here says, a greater than 0. When a is positive and the index is even, you're going to have one unique positive and one unique negative real root. So you're going to have a plus or minus nth root of a. And the positive root is called the principal root. Okay, that was one of our definitions. So that's the positive root. When a is positive and the index is odd, then there's only one unique positive and 0 negative real roots. Okay, so you just have one positive root. When a is negative and n is even, 2, 4, 6, 8, 10, your index is even, there are no real roots. We have imaginary numbers. We've already looked at imaginaries in quadratics. When a is negative and n is odd, you won't have any 0 positive, meaning the numbers aren't positive, but you will have one negative real root. And when a equals 0 and n is even or odd, you have one real root of 0. Because remember, 0 is neither positive nor negative. Now, some numbers have more than one nth root. When n is even, so when your index is even, you're going to have more than one n root, because think about it this way. 2 equals positive 4? And doesn't negative 2 square also equal positive 4? So I take the square root of 4, the answer is plus or minus 2. But when we're not solving an equation, yes, we have plus or minus. But when we're just taking the even root of something, we always just want the positive, which we call the principal root. So this would just be 2, unless I had plus or minus out here. Or if I wanted the negative root, then I'd put a negative out here, and that would be negative 2. Okay, so just know when we take the square, an even index and the even root of a radical, it's always the principal root, which is the positive value. Unless we have a negative out here or we have the plus and minus, and we want both. Okay, so that's important to know when we're just doing, and that only applies to even roots. So let's look at example 1. So example 1 tells us simplify plus or minus the square root of 16y to the 4th. Well, they want the plus or minus, so I'm going to put plus or minus. The square root of 16 is 4. Our index is an implied 2. So these are easy when you have variables. You just take this and divide it by the index, and you get 2 remainder 0, which means you pull out a y square, and you're left with y to 0 power, which is 1, and square root of 1 is 1. So our answer is plus or minus 4y squared. Now let's look at b. So it's negative square root of x squared minus 6 to the 8th. Okay, two things. You cannot separate these two terms for two reasons. For one, it's raised to the 8th power. And two, because it's under the radical sign, it's also like a fraction. When you have more than one term in the numerator and denominator, it's tied together because of the division mark. Well, here it's tied together because of the radical sign. So again, my index is going to be an implied 2. I want the negative value, negative x squared minus 6. 8 divided by 2 is 4 to the 4th power. All right, so that is my answer there. Let's look at C. So C, they want the 5th power of 243, a to the 20th, b to the 25th power. Okay, so if we plug this into our calculator, the 5th root of 243 is 3. Then we're going to take 20 divided by 5, that's a to the 4th, and 25 divided by 5 is 5, so that's b to the 5th, and we want the principal root because they didn't ask us for the negative. So this is our answer. So we only want the positive. And it's odd, so it doesn't matter. So let's look at the D. The square root of negative 16x to the 4th, y to the 8th. Well, it's an even root because there's nothing here, so it's an implied 2. I can't have a negative. Remember, that's imaginary. So there's no real roots, but I have 2 imaginary roots, and that would be 4x squared y to the 4th, and there's an I here. And it'd be plus or minus because you have 2. All right? So pause this, do the guided practice for these two, and we'll move on to example 2. All right, so example 2 says simplify using absolute value. Okay, so here's a change. So we've just been doing the radicals of things, correct? Now, there's something that we've never considered before. When we have the index is even, and when you take it out, and you have a variable, it only applies to when you have variables, and the power of the variable is odd, you must use absolute value sign. So let's think about that's why that is. So when we have the 4th root of y to the 4th, okay, so this is even, that's going to equal to y to the 1st. That is odd. So when the result has an odd power of a variable and the index is even, you must use absolute values. Let's think about it. If I gave a value of 2 for y, that would be 2 to the 4th, I would get 16. If I did negative 2 to the 4th, I would also get 16. So to ensure, because if I wanted the negative root, I would have a negative out here because it's even. But I don't, so that implies that I want the principal root, which is a positive. To ensure that, I must put absolute value around the variable. And that only applies when you have the variable. So let's look at example 2b. It says the 6th root of 64, and then x squared minus 3 to the 18th. So it doesn't matter that this is complicated. This is all tied together and it's raised to the 18th power. It's like if I had y to the 18th power. Okay, so the 6th root you put in your calculator, 64, let's look at it. Oops, sorry. Is going to be 2. Right, because 2 to the 5th is 32. So 2 to the 6th is going to be 64. So that's 2. So we don't worry about constants. Now, there's a variable in here. So again, we do 18 divided by 6 is 3 with remainder 0. So there's nothing left under here. So we have x squared minus 3 to the 3rd power. So because this index is even, we have a variable, when we take it out, even if it's binomial, is raised to an odd power, then my answer must be x squared minus 3 to the 3rd in absolute value signs. Okay? So the rule basically says when you have an even index and a variable under the radicand, or as a part of the radicand, and when you take it out, and if it's raised to an odd power, you must take the absolute value to ensure that we are getting the principal root or only the positive root. Right? So pause the problems, do the guided practice 2a and 2b, and we'll look at the real world example 3. Okay, real world example 3 says, if c equals the 5th root of b squared represents the number of collisions and b represents the number of bicycle riders per intersection. Estimate the number of collisions at an intersection that has 1,000 bicycle riders per week. So what are they asking you to do? All they're asking you to do is, we have c equals the 5th root of b squared. They want to know, estimate the number of collisions at an intersection when you have 1,000 bicycle riders. Well, what is bicycle riders? That's b. So basically we're saying c equals the 5th root of 1,000 squared. And if we put this in our calculator, because we obviously can't do this in our head, put it in our calculator, we get approximately 15.85 collisions. So we round it to about 16 collisions here. Now, what does part B ask us? So we're just using the formula, that's all. It says if the total number of collisions required in 1 week is 21, estimate the number of bicycle riders. Well, then we have 21 equals the 5th root of b squared. So the first thing I'm going to do, I'm solving for b, right? So I'm going to flip the equation. Well, to get rid of this radical, because the index is 5, I have to raise it to the 5th power, because that means I need 5 of them. So I'm going to do the same thing here, and I'm left with b squared equals, oops, this is to the 5th, 21 to the 5th power. Then I have to take the square root of both sides, and I use my calculator. Of course, you would get a plus or minus, but we're talking about quantity, measurement, so we only want the principal root. So that's approximately 2021. All right. So what they're wanting you to do is actually use your calculator and estimate it. So when you put it in your calculator, you're going to estimate by just using rounding to whatever. They say the 10th place, that's 1 decimal place. That's 2. The 100th is 2, thousandths is 3, and so on and so on. So you need to know how to use your calculator and put something other than a square root in. That's when you use the math button. All right, so stop the video and do the guided practice 3A and 3B.